Today we'll be talking about the cross product. So first off, let's consider three-dimensional vectors, vector A and vector B. Now vector A will have the components AX, AY, and AZ, while vector B has components BX, BY, and BZ. Now what we want to do is find what A cross B is equivalent to. Now, we can just memorize the formula for this, but we can also recognize that the cross product of these two vectors is just the determinant of a 3x3 matrix. The first row will be our unit vectors, I, J, and K, representing X, Y, and Z respectively. The second row will be our first vector, A, and its components, so AX, AY, and AZ. And finally, the third row will be our second vector, BX, BY, and BZ. Now, when we're considering the determinant of this 3x3 matrix, we must first off recognize that A cross B is going to give us another vector. Now, this is unlike the dot product in which we get a scalar instead. No, A cross B is another vector. So when we're evaluating this, what we find is that it's going to have these three components. So let's call this other vector C. So C has the components of CX, CY, and CZ. So when we're looking for the component CX, we want to look at our unit vector I, which represents X, and we'll eliminate this top row and the leftmost column. So we end up with this 2x2 matrix, and we want to find the determinant of this, the determinant. When we take the determinant and multiply by -1 raised to the power of this position, namely 1 plus 1, it gives us 1, then we are left with the coefficient of CX. So let's do that. So when we find the determinant, we find that we have AY times BZ minus AZ times BY. Now we follow the same steps for CY. We find that in this case we have J, so we want to ignore this middle portion, and we only have the leftmost column and the rightmost column, and we always ignore the top. So we have, in this case, AX times BZ minus AZ times BX. And now in this case, once again, we have -1 raised to the power of the position. In this case, it's an odd number, so it's 3. So we find this is still -1. So we add a negative sign in front. And finally, CZ, we say we'll consider the first two columns, one for K, and once again, we have -1 raised to 1 plus 3, which is the fourth power, which is a positive number. So we have, in this case, we have AX times BY minus AY times BX. And thus, when we put these three components together to create C, we find that the cross product of A cross B with the given components is just going to equal to AYBZ minus AZBY, comma, and here we can flip this, or not flip this, we can multiply the -1 out. So we have AZBX minus AXBZ, and finally AXBY minus AYBX. And that is how we can figure out the cross product.